So a drugs company claims that 75% of patients suffering from depression recover when treated with a new drug. A random sample of 10 patients with depression is taken from a doctor's records. Okay, write down the obviously percentage means binomial distribution. Binomial distribution. And now we have to write down the definition. So this is going to be x equals to number of successes, so number of recoveries, and the distribution is going to be n is 10 and p is 0.75. Done. The next question was, find the probability that the treatment will be successful in exactly 6 patients. So B is probability of x equals to 6. Now in the table we don't have 0.75, in the table we have up to 5. So here we have up to 0.5. So the probability given in the question was up to 0.75. So we cannot look up the table. So whenever you cannot look up the table, you can use the formula. So the formula is NC A, so this 6 is A, so it would be N is 10, CA is 6, then 1 minus P is 0.75 to the power N minus A, which is 4, so P is 0.75 to the power 6. So let's calculate this. This is going to be 10 C 6, which is 210. Then we have 1 minus 0.75, this is 0.25, so 0.25 to the power 4, this is this, multiplied by 0.75 to the power 6, this is this. Now we can multiply this with 210, and the answer is 0.14599. So let me just cut this, 0.14599. Okay, now the doctor believes that the claim is incorrect. Okay, incorrect means 75% is wrong. So without, we can just write this down. So H naught is P equals to 0.75. Before reading the question we can write this down. Okay, so the doctor believes that the claim is incorrect and the percentage who will recover is lower. Lower means H1 is going to be less than 0.75. This can be written even before reading the question. Okay, from her records she took a random sample of 20 patients. Remember, number of patients was n, so the distribution now has changed from x to y. So 20 patients, probability of success is same, so this is different now, who had been treated with the new drug. So number of recovery is 13 recovery, so that is the random variable, so that we have to test. So remember, the random variable is always going to be matching with the H1, so less than, it means y has to be less than or equals to 13. That's how it works. Okay, stating your hypothesis clearly test at the 5% level of, that is the threshold of rejecting H naught, 5%. If this probability is 5%, we have to reject H naught and the doctor's belief. Okay, now first of all, we cannot use the table because 0.75 is not in the table, although n is not large and p is not small, so we cannot do the approximation either. So this is a problem. We cannot use the table because in the table this is not there. We cannot use the approximation. So the only thing left to do is the PDF, the formula, but it will be very long because y is less than or equals to 13. That's a very long calculation. 0, 1, 2, 3, 4. It's huge. So in this situation, there is a special thing that we can do. We can switch the probability of success. How can this be done? So let me explain. If you take the success as the other one, meaning instead of taking this as the success, if you take the other one, so that means 1 minus 0.75, which is 0.25. So if you reverse the sum, completely, meaning not recovering. So if you make the success to be people who do not recover, the same thing will happen, no problem at all. So let me explain here. So if we write x and y has been done, a equals to number of people who do not recover. So we are taking the failure as the new p. So p is going to be 1 minus 0.75, meaning 0.25. So the distribution is going to be n is 20, now p is 0.25. Okay, now in that case, if you think about it, previously it was less than or equal to 13. So what does that mean? If less than or equal to 13 people recover, so there are 20 people in the sample, so if 13 people recovers, that means 7 people do not recover, If 12 people recover, that means 8 people do not recover. If 11 people recover, that means 9 people do not recover. If 10 people recover, that means 10 people do not recover. In otherwise, what's happening? Y is less than or equals to 13. So this means y is less than or equals to 13, meaning 13 or less people do not recover. And here, what's happening? A is greater than or equals to 7. So this thing can be converted to this. The probability can be switched as well. So we can have the test of the hypothesis by switching the distribution altogether. So what we can write is probability of A is greater than or equal to 7. So now using the distribution table, because both 20 and 0.25 is in the table, we can, this is a rather switching the distribution type of a technique. Instead of using the approximation, instead of using the PDF, this is just a special irregular way of doing it whenever the probability is more than 50%. So this, by this discrete distribution, we can write probability of A is less than or equals to 6. Then we can look up the table. Now we need n equals to 20. So 10, 12, 20. Great, n equals to 20. Now we need p equals to 0.25. So this column is 0.25. This column is 0.25. So for this column, what we need is the value of less than or equals to 6. That means 0.7858. So if we subtract this, 1 minus 0.7858, that is 0.2142. Now 0.2142 is, if you multiply by 100, is 21%. That means it is not within 5%, it is more than 5%. So not significant. If it is not significant, accept H0. So if you accept H0, so the claim was not right, you have to write down the answer in context. What was the claim? The claim that recovery chance is lower. So that was the doctor's belief. The doctors believe is not correct. That's it. So the next question. Okay, now what we have to do, from a sample of size 20, find the greatest number. Remember, whenever they say greatest number, they're actually talking about the random variable. Remember, whenever they're talking about the greatest number in a hypothesis test, they're just doing the reverse, the opposite, meaning the random variable. The random variable in a hypothesis test is called the critical value. So anyway, so we need to recover for this test in part C. So if you have to do, let's do question number D. Again, H0 is P equals to 0.75, H1 P is less than 0.75. This time we don't know what the random variable is, we know the probability known as the significant level. For this particular sum, the significant level is 1%, that is the probability. So that means if the random variable was known, so the critical value, so let the random variable x is less than or equals to the critical value, which is going to be, by the way, just like before, let's take this directly. So let's take the distribution directly because the sum is the same. So I'm going to take a directly. So the probability of a is less than or equals to, by matching this. Now this thing is unknown, critical value. This is the critical value. This critical value is unknown. So this probability has 1%, 0.01. So we have to look up the table. So let's look up the table for the distribution where n equals to 20, p equals to 0.25. So n equals to 20, p equals to 0.25. So we have to look for this probability which is closer to 0.01. 0.01. This is what we have, 0.02, and this is what we have, 0.00. So which one is closest? So okay, let's backtrack. Let's backtrack and do this from the beginning. So what we have to do here is, okay, so sample size is 20. That means, remove this. Okay, so this is the null hypothesis, this is the alternate hypothesis, and since 20 sample, so the distribution is going to be y binomial n equals to 20, p equals to 0.75. So by this distribution, the random variable that we have to find, so that greatest random variable, that has to be y, is by this less than or equals to c, and the probability now is given 0.01. Since we cannot do this, so what we have to do is we have to convert this just like before. So if you convert this to the different distribution a, so this would be 20, this would be 0.25. So just like before, so this was 20, this was less than or equal to, this will be greater than or equal to. So this was a, this is less than or equal to, this will be greater than or equal to. 20 minus 13 is 7. So 20 minus c is going to be 0.01, just like before. Now we have to find this portion. Now this portion is a bit cumbersome, so let's use one alphabet. Let 20 minus c equals to small letter a. That means probability of a is greater than or equals to a equals to 0.01. Now by discrete rule, if you want to find less than or equal to from the table, this is going to be 1 minus probability of a is less than or equal to, this will be 1 less, a minus 1 equals to 0.01. Let me do it here. That means 1 minus that is going to be probability of a is less than or equals to a minus 1 equals to 0.99. So now we have to find what is the closest equivalent. So this is 20 and this is 0.25. So the closest to 0.99 is here, 0.999. This is more. So this is 0.996 and this is 0.986. The closest is this one, 0.9961, because this is 61 more than 0.99 and this is a bit less, so this is the closest, so 10. So a, this value is going to be 10. So therefore this value a minus 1 is equals to 10. So that makes it a equals to 11. So 20 minus c is equals to 11. Therefore c equals to 20 minus 11 is going to be 9. So that is the greatest value. So the greatest value is 9.